When we see this word normally distributed, that means we should be thinking about a bell-shaped curve. And the bell-shaped curve means we could use a z-table to help us estimate probabilities. Okay? So for this question, we saw normally distributed. That means we want to think z-scores. That's the long and short of that. They tell us the mean is 14, the standard deviation is 3, so we need those numbers to calculate a z-score. The z-score is always the number you're trying to convert to a z-score, subtracted by the mean, divided by the standard deviation. So they want to know the proportion of brook trout that are between 12 and 18 inches. So the normal distribution is always centered right here at the mean, so 14. So 12 would be right here, 18 would be something bigger than the mean. So they're asking for this area under the curve of a normal distribution. So what we want to do is convert 12 and 18 to z-scores. We use an online table to calculate to convert those to probabilities, and then we subtract them and we're done. So to convert 12 to a z-score, we just plug 12 in for x, 14 for the mean, and 3 for the standard deviation. So that's negative 0.66667 roughly. And to convert 18 to a z-score, plugging in 18 in for x. So there it is roughly as a decimal. Those are our two z-scores. So what we want to do is go to Google. I'm going to type in z-score to probability calculator. You could use a table where you have to manually look it up like in a textbook, but this is quicker. So this website probably would work. It looks a little complicated because there's a whole bunch of different boxes, but we have a z-score. We're trying to convert it to a probability, so let's use this box down here. So if we go to this first z-score, negative 0.6667. So I'll plug in negative 0.6667. And so the probability we want is the probability to the left of that z-score. We could do it to the right. These other ones won't help us. So either of these two, I'm going to use the probability to the left. And what that tells us is this area in the normal distribution over here. I'll draw an arrow. It told us everything to the left of that number 12 is 0.25248 in the normal distribution. It's got a 25% chance of being less than 12, basically. Then I'll plug 1.3 in there. And so again, the area to the left is 0.90878. So that's saying all this area to the left of that 18 that we drew, including this other area, is going to be a little over 90% chance of having something less than 18 inches. Okay, so let me color code that actually. So this is the blue area. That's what the table just told us. And then this is the red area. So that's this over here. So to find the area in between, we just subtract those two. We do 0.90878 subtracted by 0.25248. 0.6563. So that's the probability of being between those two. When you subtracted those two areas, it's like you took the whole blue area, you took out the red area, which just left us the area in between, which is what they were looking for in this question. So that's our answer.